Hey everyone, so in this video we are going to solve LeetCode Weekly Contest 501. So let's start. Here is the first problem. In this problem that is we are given an array nums of length n and we need to construct a new array of length 2n such that the first n elements are the same as nums and the next elements are the elements of nums in the reverse order. Okay, and then we need to return this array. Let's create a vector answer and assign it to the nums and then add the elements of nums in the reverse order. Okay, let's move to the next problem. Here the problem says you are given an array of strings chunks and the strings are concatenated in the order to form a single string s. Okay, and you are also given queries and in each query you are given a string. Now let's define a word. A word is defined as a substring of s such that it contains lowercase English letters. It may include hyphens if each hyphen is surrounded by lowercase English letters and is not a part of longer substring that also satisfies the above conditions. Okay. Any character that is not a lowercase English letter or a valid hyphen acts as a separator. Okay. Now return an integer array answer such that answer of I is the number of occurrences of queries of I as a word in S. A substring is a contiguous non-empty sequence of characters within a string. Chunks is order of 10 to the power 5, so it is expecting us to solve in linear time. It may consist of English letters, spaces and hyphens. Okay, these three kind of characters will be there. So first of all, let's say we have concatenated the string into a single string. We have concatenated the chunks array of strings into a single string. Now we need to separate out this string as the words. Okay, now how are we going to separate out these words from this string? One thing is, if there is a space then the word needs to be separated. Okay, and if there are more than two hyphens, more than one hyphen consecutively, then also the word needs to be separated out, because a hyphen can only be surrounded by lowercase English letters. Okay, so these are the two conditions, and as hyphen needs to be surrounded by lowercase English letters, then in the starting or ending an hyphen cannot be there in a word. Okay, so let's make an count array of the words, because in the query we are given strings and we need to return the count of the words which are there in the string. For this, let's make an ordered map which will contain the count of words, and also let's say there is a string. Let's define a variable string which will contain the current word. let's say w, current word, and iterate over the chunks. Now iterate over the characters of this chunk. If our word is empty, then if the character is a space, or if the character is not a space, or the character is not hyphen, then we are going to put this into the word. Otherwise we are not going to do anything. Else, if the word is not empty, then if let's say the current character is space, then if we'll check if it is space, then we'll check, then it needs to be, the words needs to be separated out, we will put into the count array. One another thing we need to check is the word should not contain hyphen in the end. So if the word is not empty and word dot back equals to hyphen, then just pop the last character, that is hyphen. If word is not empty, then we will put into the count array. And clear the word. Else, if hyphen is there, in this case what we are going to do is we are going to check if there is a hyphen and the last character is also hyphen, then we need to separate out it this word. Okay, we will pop the last hyphen, and because there are more than one hyphen consecutively, so we'll pop the last hyphen and insert into the count and clear this. If the last character is not hyphen, then if the word is not empty, we will simply add this hyphen there. Else, if it is a lowercase English letter, then we are going to simply push this. In the end, after traversing all the chunk array, we will check if this array is not empty. If word is not empty and word is, the last character is hyphen, we will simply pop this last character, and if word is not empty, we will put it into the count array. Now finally make a answer array and iterate over the queries. First, okay, var dot pushback. Two 1 2 1 1 and the last is 1 0. Okay, sample tests passed. Let's submit it. This output 110111. for this case. What have we missed here? If it is a hyphen, then if the word is not empty and the last character is hyphen, then simply put it. Okay, and word, make the word clear. Otherwise, simply push back this hyphen. This looks good. If there is a space and the last character is hyphen, then pop back this hyphen. If word is not empty, simply make insert into the count array and clear this word. Oh, this should be end, because if it is empty, then if C is not equals to space and if C is not equals to hyphen, in that case only we will push back this character. Okay, let's move to the next problem. In this problem, we are given a nums array, nums integer array. You can perform the following operation n number of times. In each operation, you are given, let's say you choose two indices a and b, and nums of a is divisible by nums of b. Then replace nums of a with nums of b. Finally, you need to return the minimum possible sum of the array after performing any number of operations. Okay, so let's take an example of this test case. Now first of all, let's sort this array. After sorting, it becomes 2, 3, 4 and 8. So if we think of the, let's see the constraints, 10 to the power 5, so they are expecting a solution of order of n or n log n or n log n into log n. So n square is not accepted here. So if we think of a brute force solution, n square we can easily think of, because let's say iterate over for each I iterate over the array, okay, and for each j also, j greater than I, iterate over all the elements j greater than I. And if let's say nums of j is divisible by divisible by I, then simply replace nums of j with nums of I, right? And this guarantees our final sum of the array to be minimum, right? Why is this so? Because we have replaced each of the elements with its minimum divisors, and finally the sum of the array will be minimum. There is no other way to minimize the sum, and this solution works in order of n square. We need to optimize it. If we look further closely, what we are doing exactly here is we need to we do not need, for each I we do not need to iterate over all the elements j. Instead what we need to do is we need to only iterate over the multiples of nums of I. Okay, because this is only what we care. Nums of j here is multiple of nums of I, so this is only thing we care. So we only need to iterate over multiples of nums of I instead of whole array. This will improve our solution to n log n or n log of maximum of these elements, let's say a max. So let's talk about this improved solution. Let's take an example of this sample test case only 2 3 4 8. What I am saying is, for each I, let's say currently we are at element 2 starting from 2. For the first iteration what we'll do is iterate over the elements of 2. 3 is not a multiple of 2, 4 is a multiple of 2, so replace 4 with 2. 8 is a multiple of 2, replace 8 with 2. Now this, for the second iteration we move to 3. 2 will remain as it is. Are there any multiples of 3 in this array? No, so we will keep it as it is. For now we do not need to make any further iterations because we do not have any unreplaced elements in the array, because the further elements are replaced. So this is this will help us get the minimum sum of the array. This is the final array which will look like, and 3 to 5, 4 plus 4, 9 will be our the minimum sum, right, for this sample test case. Okay, and let's take an example of the general array, how we are going to solve this problem. Let's assume all the elements are sorted order a1, a2, a3, a4, a5 up to an. And for now let's assume these all are distinct elements. So how we go about solving this? So we will iterate for each I. Let's iterate, and let's iterate the multiples of a of I. Okay, multiples of a of I. And let's say there is a element j which is a multiple of I. Okay, and it is not replaced yet, then we will simply replace it with a of I, otherwise leave as it is. Okay, so doing this will give us the final array a dash having the minimum sum, because each element finally will be replaced by its smallest divisor. Okay, let's see how we can implement this solution. For encountering the duplicate elements, first of all let's take the maximum value of the array in nums. This is 10 to the power 5. Create make a count array. Initially count of each value from 0 to a max minus 1 is 0. Now add the elements in this count array. This is for handling duplicate elements. Now iterate over. Now also make a variable to collect the sum. Now iterate over all the elements one by one. If count of I is 0, this means this element is either replaced or it does not exist in this nums array. We do not need to iterate over multiples of I, so we will just continue. Otherwise we will iterate over the multiples of I. Let's so we will replace here j is a multiple of I, so we will replace j with I. So our contribution of it sum its to sum is I into count of j, and as we have replaced and added its contribution to sum, we will just mark it as 0. Okay, and finally return the sum. And as I and count j are integers, let's make it long. 7, 9 and 21. Seven, 9 and 21. Okay, let's move to the next problem. Here the problem is you are given an integer n, and integer prices of n. Your price of I is the apples, price of the apples at shop I. You are also given a 2D integer array which contains the roads from U to V having cost and tax, represents a bidirectional road. Cost of I is the cost to travel without carrying apples. Tax is the multiplier applied to cost I when we are having apples. For each shop I, you can either buy apples locally at shop I with prices I, or travel empty to some shop j using any number of roads, buy apples for prices j and return back to shop I while carrying apples, paying cost into tax on each of the roads used on the return trip. The forward path where you travel empty and the return path may be different. Okay, a return integer answer of length, and where answer of I is the minimum total cost to buy apples starting from shop I. Okay, so let's see the constants. It's n is order of 10 to power 3. Roads dot length is also order of 10 to power 3, so they are expecting a solution in order of n square or n square log n. Let's see how we can solve this problem. Okay, so let's say we have some graph. Let's say 1 to 2, 1 to 3 there is a directional edge, then 1 to 5 there is a directional edge, then let's say bidirectional. All edges are bidirectional, so let's say there is also a 3 to 4 bidirectional edges having cost and tax all different. Let's say C13, T13, C34, T34, okay, and C35, T35. So this is the graph. How do we solve this? Let's say we are solving for index 1. For index we are solving this problem. By this what I mean is we need to either purchase apples at I at price of 1. We need to purchase apples at 1 at price of 1, or we will go to some other index, purchase apples from there and return back. And we need to make sure, we need to take into account the weight of age. While going empty, we need to take into account only the cost. Okay, while going empty, we need to take into account cost as Cij only. With apples we need to take into account the cost as Cij into tax of ij. These are the only two differences. So while going to index j, we only need to consider the cost, and while returning we need to consider on cost into tax as the weight of the age. So this transforms this problem into a simple minimum shortest path problem, which can be solved with the Dijkstra algorithm. So here what we will do is we can maintain a cost array. So while going forward from, let's say we are solving for index I, we can take a cost array where cost of j will represent the minimum cost to reach j from I, okay, with no apples, right, empty. Okay, so this can be easily solved with Dijkstra algorithm. Okay, the simplest case. Dijkstra algorithm in n log n time. And now the another thing is, let's say we have found the cost to reach each node j. Now we need to return back. Okay, so for returning back we need to consider the cost as cost into tax for each edge. Now this can also be solved with the Dijkstra algorithm. Finally, we need to find the minimum cost to reach index idx from each j, right, with the minimum cost. This also can be solved with Dijkstra algorithm. So what we will do is we will, let's say, make a minimum cost array. This is for return, right? For each I, this contains the minimum cost to purchase apples at any index and come back to I, and come back to I. So basically what I'm saying is you need to traverse idx to some index, let's say j. Okay, you purchased apples here and then you will go to I. This minimum overall cost is referred to as this minimum cost, mn cost of j, mn cost of I. Okay, and finally our answer will be mn cost of idx. How? Because this is the same thing. What we want to do is we need to travel from idx to some index j, purchase apples from there and come back to idx. Okay, this is the original problem and our answer will be this. For doing this, what we can do is we can insert so the only key change here is, while returning back, the only key change is we can insert means we can start from any index j, our final goal is to reach index idx with the minimum cost. So we will insert the cost of reaching to each index j and their price of purchasing apples from there into the priority queue, and we will start from each index all over the graph, and our goal is to reach index idx. This will be easily handled by Dijkstra algorithm. Let's see how we can implement this. Let's take a cost array with initially infinity. Let's also define, because cost can go over 10 to the power 9, 10 to the power 11. So let's define 10 to the power 18. Okay, and also define a visited array. Mark it as false, mark all the elements as false, and also define a priority queue. Also we need to create a graph. Here we will store the LV, cost and text for each element, iterate over the rows, insert into the adjacency list, UV, then cost, and this is text. As the age is bidirectional, so let's add the reverse age. Okay, now also have answer array and traverse for each index. Now our problem is to solve for index idx, and let's put this inside this loop because we do not need this outside of this loop. We are solving for each index separately. Okay, let's put, we will start from idx, right? And so as you are starting from idx, the cost for starting will be 0. Now while the priority queue is not empty, we will keep on polling the current cost and index u of the top element. If this element is visited already, continue, otherwise mark it as visited. Now travel over the edges connecting to u, that is v, then its cost, then its text from u. If cost of v is greater than cost of u plus cst, we will not take into account text here because we are just going to some index empty. We have not purchased apples yet. If this is the case, then update v equals to cost of u plus cost of this age, and also insert into the priority queue. This gives us the minimum cost to go from index idx to each node j with the minimum cost. Now we have reached to some index j and we have purchased apples there. Now we need to come back to index I. For that, let's make this array. Okay, purchase apples and assign the minimum cost. So for index I, minimum cost will be initially cost to reach I and purchase apples from here, and also mark visited at false here. Okay, and also put it into the priority queue. Okay, now just we need to calculate the minimum cost array. So this is the only unique difference from the above part here. So in this case we are starting from every node I, and our final goal is to reach index idx with the minimum cost. Okay, if this is not empty, then replace here cost with minimum cost. Also we need to take into account here text, because we are having apples this time. And this can go over the integer range, so make it long. Our final answer will be minimum cost of index, and return our answer array. So this should work. Let's see. 6-3. Okay, next one is 8-4-6. Okay, third sample test case, it is 5-11-1. Okay, let's submit it. Great. So we have finally solved this problem in using the Dijkstra algorithm, and our time complexity is order of n square log n. N is for iterating for each of the index, and inside for each index we are using the Dijkstra algorithm. It takes order of n log n. So overall time complexity is n square log n. So this is it for this video.